Good morning. I thought this was set, but it's not. I'm going to show you how kind of to derive the formulas for the exterior and interior angles of a polygon. So it's kind of all based on triangles, which shouldn't be a shock at this point since pretty much all of geometry is based on triangles. Probably not all, maybe 2/3. Anyway, we all know the triangle angle sum theorem, which is the fancy way of saying the angles in a triangle add up to 180 degrees. And then there's this little thing called triangulating. So we can take triangles, or not triangles, polygons, and triangulate them. Let me show you what's not triangulation first. Let's say we have this little pentagon over here. If I asked you to divide this into triangles, people would tend to go like this. And just keep drawing those. That is not triangulating. Triangulating means that you choose one vertex, and then from that vertex, you draw a segment to each of the other vertices that you can. So obviously there's only one here. Well, if each triangle has 180 degrees, then wouldn't this quadrilateral have 360? Which you know is true from the quadrilateral unit. So it had four sides. Here, I'll make a little chart. Four sides, two triangles. And we multiplied each triangle by 180 and got 360 degrees. All right, so then if we look at the pentagon and we triangulate it, choose one vertex and draw a segment to the other ones, we have five sides and 1, 2, 3 triangles. 3 times 180 is 540 degrees in the pentagon. Now, obviously, there's like a bazillion polygons, so you're not expected to memorize this. You don't need to. I mean, we have memorized the triangle is 180 and the quadrilateral is 360, but after that, there's no need to memorize. So let's keep going and see if you guys can come up with what this formula might be. So right now, we have four sides, two triangles, 360 degrees. Five sides, three triangles, 540 degrees. This one has 1, 2, 3, 4, 5, 6 sides. And let's triangulate it. 1, 2, 3, 4 triangles. Each triangle has 180 degrees, so this hexagon has 720 degrees. That's the sum of the interior angles. All right, so let's look at the next one. It has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it's an octagon. If we triangulate it, it has 1, 2, 3, 4, 5, 6 triangles. 6 times 180, because each triangle is 180, is 1,080 degrees. All right, hopefully you're starting to see a pattern. So I'm going to go right here. I'm going to put the 4 and 2 and 5 and 3 here also. Oh, it's going to go away anyway. All right. This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So it's a decagon. How many triangles do you think it will have? Without even drawing and triangulating it, I know it has 8. All right, so I'm going to draw this and double check so you can see that that's true. 1, 2, 3, 4, 5, 6, 7, 8 triangles. So if it has two fewer triangles than the number of sides, it looks like. Well, 8 times 180 is 1,440 degrees. All right. So what if we didn't know the number of sides? This number of sides was called n. What do you think we need to do to that n to give us the number of triangles? We had 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. 8, 6, 10, 8. We just subtracted 2. So if it has n sides, then there's n minus 2 triangles. And each triangle has 180 degrees. So the formula for the sum of the interior angles is n minus 2 times 180. All right, so take out this paper if you have it, and we're just going to write that right here. The sum of the interior angles of a convex polygon, meaning it doesn't have any dents in it, is n minus 2, number of sides minus 2, times 180 degrees. And it works just like this. What is the sum of the interior angles of a 112 gon? Well, that means n is going to be 112. So we have 112 minus 2 times 180. 110 times 180 is 19,800 degrees. It's a lot of degrees. But that's it. That's all you have to do. So sometimes you'll be told blatantly, sometimes you're going to have to count. But to find the sum of the interior angles, you just count up the sides, subtract 2, and multiply by 180. If the polygon is regular meaning that all the sides are congruent, then the measure of each interior angle can also be found. The first step for that is to do the total, n minus 2 times 180, the sum of the interior angles, and then divide that by the number of sides. Just like in a triangle, if it has 180 degrees and it's equilateral, we divide it by 3 and get each angle is 60. So what is the measure of each angle of a dodecagon? Dodecagon means n equals 12. I like to do it like this. First, I do n minus 2 times 180. So 12 minus 2 times 180. (1800 degrees). Then, this is just the way I like to do it. I take the 1800 and I divide it by 12 because that's how many angles a dodecagon has. And 1800 divided by 12 is 150. So each interior angle is 150 degrees. All right, those are the simplest examples. If you look at the next section, the next topic, there's examples where we actually use these formulas with actual figures or some different information. You can manipulate them, but this is the basics for the sum of the interior angles. And I'm going to stop this video and do the exterior video or angles on another one.